Yeah, okay. Hi, hi. So today I'm here to talk about wine world. What I have continued last time. So let's try to do some classifications today. I'll try my best to do it complete it within only a few minutes, right? Um, so I think it's better to talk about classifications because actually the next model we can talk regarding this scenario is classification. We were talking about wine world dataset, right? So let me keep this here. All right. Okay. Let's have a look at the dataset once again after a long time. Then you might have forgetting this dataset completely what I have prepared, right? Uh, Give me the right. Okay, let's see. You can remember that we have split this dataset into two parts using CA tools, right? Okay, so this is the dataset. Um, right. So as you remember, there was a color, right? Whether that's red wine or white wine. So we are trying to use a classification model to classify this. There are a couple of classification models I hope to go through. K nearest neighbor, right? K nearest neighbor classification model. So first of all, let me give you some idea about this. When we go further sessions, I hope to talk about all these metrics and the mathematical intuition behind this. But for now, I don't think it's uh, it's not better to talk about all these things. Then we will get bored with that. Then you can see these numerical variables. Actually, most of the times we will prefer this k-nearest neighbor for numerical variables, but even we can use them for categories. You know that there are two types of categories, uh, nominal and ordinal, right? So then there are some levels, some categories. There are some levels we uh, can show the strength of the characteristics, right? It's like good, bad words like that, right? So uh, there are so many categories like that. So when we can assign some weight, so we can assign some numerical values to implying them. Hence, we can convert them into numerical formats, just like print them into dummy variables likewise. Then even we can deal with them using k-nearest neighbor, right? Okay, so here these distances may be measured, right? For example, let's say there are some data points scattered. Likewise, uh, there are two labels like this, right? Actually, this is a supervised model, right? This is a supervised model. You can use this as a regression model or classification model as well. So let me show you how it's working. Hope there must be circle. I don't know how it will work with radius. No, does not work with radius. Right, okay. Let's say there is a center of this circle. You can see here, approximated. Then it's talking about three neighbors, right? And with respect to this circle, there are three observations inside this circle, and the priority will be counted, right? Uh, the majority will be counted here. What about the majority? Majority is given for blue, then the next observation also will be classified as blue, right? So this one will be classified as blue. Let's say when it is drawn up further, a higher number of red counts are counted, right? So the majority, 3, 4, 5 here, they're only 4, right? Then the majority class is red, then this C is given red label red, right? Likewise. So there's a thing here. So likewise, all these distances may be measured first of all in this model, right? Right, okay. I'll talk about this mathematical intuition later. For now, I think it's better to go through this codes, right? Um, Today I don't have too much time to talk about this, but I will try my best to make it short and teach you everything what you need. There are a couple of ways to do this k-nearest neighbor classification. Today I do this using library class, right? Library class will be used, right? Library class will be used, right? Now already this is split into two parts as train and test, right? But in advance we have to scale this, otherwise you can see each of these attributes are in different ranges. They are spread out in different ranges. Then when we classify this when we try to find out the distance, it will be working, but it is not meaningful because they are having some different weights. Therefore, it will be affected for this classification. In order to make it meaningful and reliable, and making the contribution of all these variables efficiently, we have to scale this, right? So there is a default function which will help us to scale these just so we can use the scale function. Scale function is nothing else. Function, let's say scale function x. What does it do? This is done there, right? X minus here inside parentheses mean of x, which is the attribute we will consider standard deviation of x, right? Likewise. So this can be done using the scale function without using this function because it is given as a default function in R, right? So I will keep it there. Now train underscore scale function, scale attribute must be formed, right? So I will use this scale, then scale, train has to be scaled, You can see that there are 30 number of columns, but we will not convert this 30 column into it may not be scaled out because that's our output, that's our response. It should not be going through. Yeah, what happened? Train square brackets. Where is square brackets? Put a comma. minus 13, 13th one is eliminated, right? It is not taken for this. Then test. After that, test, scale, scale, scale inside parentheses. Actually, when we do using this scaling, we will do normalizing that, right? According to the normal distribution or Gaussian distribution, we will adapt it with the Gaussian distribution. Then all these z values will be counted, right? Okay. Now, sorry, text, square brackets, put a comma, minus 13, right? This will be omitted, right? Okay, now it is ready for the analysis. I wanna predict for test prediction, testing set prediction, right? Prediction, let's say it's prediction, testing set prediction. Now I'll use knn function, train equals train underscore scale, then test equals test underscore scale. Okay, then class equals a train. This should be taken based on the training set, because in this function, in this algorithm, this testing set will be labeled based on training set, right? So first of all, the training set will be studied, then these distances may be measured. Let me check whether it is being recorded, right? Otherwise, I have to do it multiple times. Right, okay, fortunately it is being recorded, right? So now, train based on color, right? So that's the class, right? That's the class. Then I put okay. How many neighbors will be included? You can change it. This is the hyperparameter, right? You can tune it. You can tune it. Even you could find it out using k false, 10k false method, right? The best optimal value for this k nearest neighbor, right? A number of events will be considered for a single cluster, will be represented by this k. Then you can change this number of k's what you assign for that. Then you can check the consistency of this model. Then test prediction is there, and these may be predicted, and all these may be predicted. Testing set may be predicted, right? Now I wanna evaluate this, right? Evaluate this confusion metric is going to be built up now table using table function. That's a default function in R, right? So what is my text? This is test column, then test underscore prediction, right? Okay, let's print this. Print confusion metrics, confusion metrics, right? Okay, let's see it, right? Okay, this is the result, right? This is the result. You can see 0. 0 stands for white wine, as I remember, right? So 961 white wines are called, predicted exactly. Then 318 number of red wines are predicted true, right? So even you could work with direct library, and you could use confusion metric function in order to find out all these specificity kappa values and all the others, right? Positive predicted rates and negative prediction rate could be found out, right? You can see that there is no issue with this positive prediction rate and negative prediction rate with this confusion metric when you would compute that, right? You could turn this into a probability using dot prop dot table function, right? Um, it's like that. I'm not trying to do that because I have done everything in my earlier sessions. Also, the model evaluation has been done. So this is what the most convenient way to do a nearest neighbor clustering. Now let's see test prediction. If you wanna check this test prediction, we can prepare a data frame using this. I can add this into a testing model test prediction of KNN equals the test underscore prediction. Then we can see how it will be look like, right? How it will be look like. Then we can see, even we could plot them, right? Even we could plot them. Let's see how far it is agreed. Um, head of the test, head of the test, head of the test. You could see that, and the rest of this data frame, you could see there is a prediction, right? Most of them are overlapped together. According to this testing set is evaluated, right? You can remember that we have split these into two parts, right? Not the scale test, right? The scale test scale was used to to build up this model, right? To go through these k nearest neighbors. It has counted all these distances, right? Based on all these distances, depending on the training set, scale training set, they have identified what about the scale testing set, then they are given labels, right? So that's what they have done. Then the final attribute has been added there at the rest of this data frame as prediction KNN. Even I could plot it. I will use library ggplot2 ggplot2 then ggplot data equals test mapping equals aesthetic x equals column, then y equals prediction spelling wrong, prediction underscore KNN, right? What I need geom line. I'll ask for a line. Okay, I have not added GG title. Let's see what about this result. Already we have evaluated this, right? Already seems like there is yeah. They once they are connected, uh, 0 0, then 1 1, right? Even there are some misclassifications. That's why 0 comma 1 and 1 comma 0. So I asked to put a geom line. That's why they are connected, right? So actually, in this type of classification, we are not able to use this geom line successfully. It does not make sense, right? Right, okay. So what about the accuracy of this model. Accuracy of this model is, I could say, a mean of some mean of what um, test prediction KNN equals with yeah, even we could do it like this using confusion metric. Accuracy equals confusion matrix. I need 1, 1 and plus, right? I'll do this promptly, right? All these. You could use current library to do this easily with a single function. We could use summation means. I have used the longest way, right? How does it work? Does it work? Happen to this one. Is it all right? Is it all right? Should be work. Right. Accuracy. Let's see. It's 99.07. It's a good accuracy, right? But you can see this, right? Population was your model. Actually, this is the truth because we can never acquire the true scenario most of the times in an environment when we are talking about environmental scenarios, things we can never obtain all these observations. Therefore, there is an error. So statistically, we can propagate that. Statistically, we can deal with them, right? So we must be able to find out the shape of those distributions, but due to so many reasons, some model may be like this, right? Not actually like this, right? Because uh, sometimes we are making some assumptions. Based on those assumptions, we are working, right? So we will count on the some particular variables, then we will miss some more variables which will affect on these scenarios, studying case, right? Case study. Likewise, right? Okay. So we have classified these two types of wines with 99%, almost 99% accuracy, right? Using k-nearest neighbor. Yes, I could give you a brief idea about this k-nearest neighbor as well. And hope you could understand it. If there is any doubt, as usual, you can ask me, right? Okay. Thank you very much. Okay. Thank you very much.